In this video, I'm going to teach you how to actually construct truth trees. Before watching this, I strongly recommend that you watch my introduction to truth trees video, and you should also have mastered the decomposition rules, which I also have a video on. If you don't know the content that I cover in those videos, there's a pretty good chance that you're going to struggle following along in this video. I'm going to cover three things: where to place your decomposed statements on a truth tree, how to know when you're finished building your truth tree, and really importantly, what order you should decompose your statements in. And I'll end the video with an example to show you all of this stuff in action. All right, let's get started. In these examples, I'm not going to be testing for anything in particular. So for instance, I'm not testing for validity. I've kind of just placed the statements on either the left side or the right side of the main branch, depending on what it is that I want to teach you and how I think I could best do that. And you should remember throughout the video that the purpose, the main function of a truth tree is just to tell you whether that initial set of statements where you've placed them is actually possible. So for instance, if you place all of the statements on the left side of the main branch, you would be testing to see whether it's possible for all of those statements to be true at the same time. Okay, with all of that said, let's go ahead and move on to the first thing that I want to show you. We'll start by learning where you should place your decomposed statements on the truth tree. Now, don't worry about the order in which I'm going to be decomposing these statements. I'm not going to be decomposing them in the optimal order. I'm just going to decompose them depending on what it is that I want to show you. And I'm doing this just to show you where you should place your statements when you do decompose them. Technically, you can decompose statements in whatever order you want. It's not against the rules, but there are better and worse ways of doing so. All right, so here's a really simple truth tree. In it, the statements P and Q and P or R are both true. So suppose that you want to start by decomposing P and Q. You'll place both P and Q on the left side of the branch like this. And remember that you'll be checking off P and Q to indicate that you've already decomposed this statement. Don't forget to do that so that you don't accidentally decompose something more than once. Then we'll go ahead and decompose P or R. And since P or R is a disjunction, it means that we're going to have to split the branch. Okay, so we're done with this tree. And I'll tell you in a minute exactly how to know for any given tree when it is that you're finished. But notice that there are no contradictions on either one of these paths, so we're going to mark them both with circles at the bottom of the path to indicate that both paths are open. There are no contradictions. All right, now let's go back to the start, and this time let's start by decomposing P or R first. In this case, you would begin by splitting the main branch. And then when you go to decompose P and Q, you would have to do so on each open branch, which means that you would get a tree that looks like this. The important thing to notice here is that you have to decompose your statement along every open branch along its paths. Since we started by decomposing P or R first, now P and Q has two available paths to decompose on downstream. There's the path on the left and the path on the right, and you need to decompose along both paths so long as they are open. As might be obvious by now, there are better and worse orders in which to decompose your statements. And we'll get back to that. All right, so now let's go ahead and say that the statement P or R or S is true, and the statement R or P is also true. If you begin by decomposing P or R or S first, then your main branch will split like this. And now let's say that you want to decompose R or P next. In that case, you're going to have to decompose it on every path downstream of that statement, which means that you're going to have to split both of the currently open branches like this. The lesson here is that you need to decompose your statements along every open branch downstream of the statement that you're decomposing. Now, we still aren't finished with this tree. We still have R or S here, and we haven't decomposed it yet, as you can tell by the lack of a check mark. So we have to decompose this. When we decompose R or S, we have to decompose it on all of the open paths downstream from it, which means that our tree is going to look like this. Notice we do not decompose R or S on the other side of the tree. Remember that each path on a tree represents a possibility. Since R or S isn't on those other paths, we wouldn't decompose it there because that possibility isn't live on that side of the tree. If that sounds at all tricky or confusing, then just ignore me. Remember the rule. Always decompose compound statements down all of the paths that are open downstream from that statement. That's it. Okay, one last thing you need to know about where to decompose your statements. Let's go ahead and say that you've got this truth tree. We'll go ahead and begin by decomposing P or R so that the tree looks like this. Notice that on the path on the left, we have a contradiction. P is on the left side of the tree here, and it's on the right side of the tree here. So we close this path. Now let's turn our attention over to L and Q. Now normally, since we've already split the main branch, we would decompose this conjunction onto both branches. However, the path on the left is closed, so we'll decompose our conjunction onto the left side of only the right branch because that's the only path that's open. And since the statement P, which is on the right side of the main branch, is already an atomic statement, there's nothing left to decompose. Our truth tree is complete. So to wrap up, you have to decompose your compound statements onto every open path downstream from that statement. If the decomposition rule that you're implementing requires splitting, then you have to split every open branch downstream from that statement. And finally, do not decompose onto any closed branches. All right, now let's quickly talk about how to know when you're finished with your truth tree. This stuff is pretty straightforward. If you have nothing left to decompose, so if all of your compound statements have check marks on them, then you're done. Just place a circle at the end of every path that you haven't already crossed out. On the other hand, if all of your paths are already closed, if every single path ends in an X, it doesn't matter if there are still statements that you haven't decomposed, your truth tree is finished. A truth tree with all closed branches is a complete tree, even if there are compound statements that have yet to be decomposed. All right, let's talk about the final thing, and that's the order in which you should decompose your statements. To be clear, what I'm going to tell you now is technically not a set of rules. There is no order that you're required to by the rules to decompose your statements in. That said, there are better and worse ways to go about decomposing your statements. If you aren't careful about the order in which you decompose your statements, you may end up with really large, unseemly, terrible truth trees that you don't want to be dealing with. Here's everything you need to know about the order in which you should decompose your statements. First, always begin by decomposing all of the statements that do not require splitting the branch. This will help to keep your truth tree as small and manageable as possible. And two, as a general rule of thumb, try to decompose statements that you know are going to lead to closing off branches. The reason is the same. You really just want to make sure that you keep your tree as small and manageable as possible, so the more branches you close off, the easier it is to do that. All right, let's go ahead and work through an example to see all of this stuff in action. Okay, here's our tree. In it, P or Q or R is true, and not P and not R is also true. Meanwhile, R implies N and L is false. Notice that we should not start by splitting the first statement. It's a true disjunction, which means that it would require splitting. We could go ahead and start with either the second or third statement, since neither one would require splitting. True conjunctions don't require splitting, and false conditionals don't require splitting. I'll just go in order from top to bottom, starting with not P and not Q, since, remember, we don't want to begin with the true disjunction. So, decomposing not P and not Q simply gives us not P on the left side of the main branch and not Q on the left side of the main branch. And since negations never require splitting, we might as well just go ahead and decompose these as well. We'll start by decomposing not P, and then we'll go ahead and decompose not Q. And so far, we've managed to just stay on the main branch. We haven't split anything yet, which is great. All right, let's go ahead and decompose the false conditional. Our tree ends up looking like this. And that's everything we can do without splitting. Our only choices now are to either split the statement that we put aside at the beginning, the true disjunction, or to go ahead and split our false conjunction N and L. And notice that it's better to start with the true disjunction P or Q or R first. It takes some practice to start seeing this, but let's look ahead a little bit. Decomposing P or Q or R first will require splitting the branch and placing P on the left side of one of those branches. That's going to create a contradiction on that path, since we also have P on the right side of the main branch. This means that we can close this branch and put it out of commission. If, on the other hand, we had started by decomposing N and L, then we would begin by splitting the branch and we wouldn't get any contradictions out of it, which would leave both paths open for further decomposition. We would then have to decompose P or Q or R on both open paths, which makes the tree more difficult to manage, especially since we still have to decompose Q or R. So it's better to decompose the statement that we know is going to allow us to close one of the paths. Now we have another choice. We can either go ahead and decompose N and L, which we had chosen not to decompose, or we can decompose Q or R. And again, it's better to leave N and L for later and begin by decomposing Q or R, since decomposing Q or R is going to allow us to close another path. Once we decompose Q or R, we'll split the branch and end up with Q on the left here and on the right here. So we can go ahead and close that path. Now all that's left is to decompose N and L. And there's only one path that we can decompose it on. And now that we've done that, we can see that we've decomposed all of our compound statements, and there are no contradictions on these two remaining paths. So they both get circles since they remain open. And we're done with our tree. Now I want to show you what would have happened had we not been careful with the order in which we decompose our statements. We could have ended up with this monstrosity. This truth tree is technically perfectly all right, but I find it visually offensive. It's difficult to manage and it can lead to a lot of mistakes. Trust me, you want to stick to the order of decomposition that I've given you. You want to decompose the statements that don't require splitting before you start decomposing the ones that do. And you want to keep an eye out for statements that you could decompose that will lead to contradictions so that you can start closing off your branches. And that's everything that I wanted to teach you today. If you want more videos on logic or philosophy more generally, you should consider subscribing. Thank you so much for watching.